welcome back to the second session of this morning, where we continue to discuss opportunities in buildings and lighting. So let's welcome the first speaker, who is Colin Timmins from the European Building Automation and Controls Association, and who will talk about perspectives on the optimization of building efficiency through automation.
Okay, good afternoon now, I think it is. I'm going to talk about something along these lines, but really to talk about some of the legislation that's currently already out there, and also something that we've introduced as UBAC, which might help us in trying to get to a way forward. As well as working for UBAC, I'm also based at BEMA in the UK. We represent manufacturers of a variety of fixed electrical appliances, such as, well, anything from distribution transformers through heat pumps, smart meters, controls, lots of things down to plugs and sockets. So we're very engaged in thinking about how you look at systems, because most of our products form part of a system, and most of the benefits that you get from our products are through impacts on the system. These are the members of UBAC, just to give you an idea of the scale of representation. A few slides to start off with, just some thoughts really in terms of what we need to think about with systems. I quite like this picture because I could ask you what's the efficiency of that light, but the simple answer is it doesn't really matter because it shouldn't be on. There's no point to it being on. And I think one of the things for controls is very much trying to stop things being on when they don't need to be. Very, very simply. But that's not just the appliance, and if you just look at the efficiency of the appliance, you can forget sometimes that the control side is just as important. And product efficiency is only part of the story when you start looking at buildings. So you could put a boiler under the forthcoming energy labelling for boilers and space heaters. You could put a boiler in and say, well, it's 90% efficient, and it's heating my house up, and that's brilliant. But in that situation, you haven't got any zone control. You're just heating up the whole house. And actually, what you'd want in that sort of situation, where you've got the occupant, you might want 20 degrees as a comfort temperature. In other rooms, you may want less, either because people are moving about in those rooms or they're unoccupied. And if you look at it, and this is a very simple, very crude example, with the same boiler in there, you get about 17% less energy. Now, don't hold me to these figures in terms of somebody said this percentage and somebody else said this percentage. I just calculated it on 25% against the delta T's, so it's a very simple example. But the important thing is it's the same boiler rated at the same efficiency, but in the two situations, because there's an improved system, you need less energy. So if we actually said in that situation, well, the system efficiency, therefore, is 90% because the boiler's delivering as much heat as it actually needs to, rather than more than it needs to, and then you went back to the other one, that system efficiency might only be 75%. So, as I say, very crude, very simple example, but just to show that the addition of controls can reduce the amount of energy that's required. So that has an impact on how much energy is used. It's not just the efficiency of the appliance. And when you get to more complex systems in buildings, you can get all sorts of oddities happening. I mean, we already had an earlier presentation reference to the lights being on with the windows. But you can get situations where you might have the blinds down and then the lighting's on and the ventilation's on. Heating comes on, but it's a bit too hot, so they put the cooling on as well to get it down. And you can have all of these elements working to maintain a comfortable environment for the occupants. It could well be that turning all of those off and opening the blinds and opening the windows will provide that optimum internal environment, or something close to it. And I think we've always got to think about the users and the building in any sort of discussions about systems, although that may be a step too far in terms of legislation. But I think the fact is, when you get to complex situations and complex systems, you need to make sure that they're working together. And this is what one of the areas that UBAC focuses on, which is building automation and control systems. And you can really look at that as a brain for all of the different elements in a complex system. So it's making sure that you deliver the optimum internal environment for the occupants, but you use as little energy as possible to do it. And it can be that over the course of time you're starting to look at different sources of energy. it might be better to turn something off for a little while because you can get some renewable energy in a short time, and something like that. There's all sorts of things that are moving forwards on this. But the important thing from our perspective is that these sort of systems, it's a big number, it doesn't really matter what that means, but there's a great potential for savings from having these systems in buildings where they should be. And also, control systems are an essential part of saving energy. But at the moment, they don't sit very comfortably within the legislation that we've got for buildings or for products. The example I wanted to talk about today, I'll just check the time. Is a system label that's been created in UBAC to look at building automation control systems. It's been developed to provide assurance that a BAC system will be installed and managed at its most sustainable energy efficient level. And to say it's managed at its most sustainable energy efficiency level is quite important, and I'll come on to that. It's something that's based on existing European standards, so we haven't created this out of nowhere. It's delivered by accredited experts trained by the industry association, so it's quite a robust scheme, and there's some element of quality assurance in there. And it's currently being rolled out across Europe. So this is something that potentially could be a legislative tool to help with looking at systems. This is EN 15232, and I won't go into this in much depth, but basically it looks at different BAC systems, so that's the only acronym that I'll try to say today, but Building Automation Control Systems. And it looks at them in different ratings, A, B, C, D, with C as a sort of benchmark. So the labelling is based on that standard. And what happens is that an auditor goes out to the building, look at all of the different elements and assign a score depending on what's there and how it's performing. And in this situation, where the total is 35 out of 100, that would be an E. But what you want to get to is a system where you've got something like 91 out of 100, which would be an A+. The important thing, and this is based on the European standard, is that a 10-point improvement means 5% of energy savings. So in that example of going from an E to an A+, then you're talking 50, it's about 50 points, which is about 25. So my maths is going haywire here. So 10%, 35, 50, 25. Is that right? Yeah, good, okay. Maths tends to fail you in these sort of situations. In terms of application, what we're looking for is for systems to be specified in accordance with the standard, to try and get the best possible system in there. And then the label comes into force as an audit at the point of commissioning and handover to make sure that it's been installed as it should have been, and then therefore it will perform as it should be. And in a sort of circular time, over the course of time, to actually look at what happens to that system over the course of time. Now that's important. If you look at a very simple graph of time, and if you assume that 100 is without any BAC system there, then typically what you might see is that over the course of time, if the system's not been optimized or maintained, then the performance will decay because people are tinkering with the system, they're adjusting things here and there, there's maintenance requirements and so on. So eventually the performance is dropping off. With a regular audit in there, that system can be maintained so that over the course of time you can address the things that are degrading the performance and pull it back onto course. In an optimal scenario, then you'll actually start to look at ways of improving that system over time. Now that may mean an investment, but you've got a tool to actually show what that return on investment will be. So it does mean that we can look at a system not just in terms of what's put in and how it's installed, but actually make sure that over the course of time it's into line with what it needs to be, and potentially it's also improved. So Inform is quite an important tool. The system's been rolled out, so last year, I don't think the colours are that great on here, so last year in Germany, France and Austria, and this year it's rolling out in UK, Scandinavia and Switzerland and so on. And we're finding that this has been very well received by the industry because it's a tool to demonstrate the impact of a system. And that's very, very important. And one of the problems we always have, we talked a little bit earlier about different percentage savings and so on. The world's not like that. The percentage saving is going to be different in every single building, and there's going to be all sorts of factors, the people, the building, and everything else that's going to affect that. So to have a tool that you can actually look at and give you a benchmark and is a real assessment of a system is very, very powerful. Oops, I've just turned it off. Oh no, turn it back on again. And these are some of the buildings that have been done. We would expect that distribution on the label would be far more weighted to the lower end in reality, but I think one of the downsides of a voluntary label is that you get people wanting to demonstrate that they've got a good system rather than people who maybe haven't, getting an indication of quite how bad it is. But anyway, as you can see, there's a number of buildings been done already. Now, I was given a brief really to talk about legislation and potential legislation, and I would put a little sort of word of caution to this. These are my personal thoughts on regulation. These aren't a formal UBAC position, but it is in line with the sort of discussions that we've been having about the best way of dealing with systems, by which primarily we mean control systems. So if we were starting now, I would say that you'd want to look at energy labelling for appliances that you buy from a shop and come with a plug, and for buildings. And we've sort of gone on this process with eco-design that we've moved into things that are fixed appliances that form part of systems. And the difficulty of that, as you can see, is that you then get into whole areas of complexity, and you can't necessarily guarantee that the label that is on that product is going to actually be applicable when that product is installed within a system. That's a real issue. It's a difficult one to resolve, but it's a very real issue. Standalone appliances are fine, but I think if we had actually started by looking at labels for buildings, that would make a lot more sense, because two things really. I mean, one, it's more relevant for the people who you want to influence to make changes, either the consumers or the specifiers or building owners, whatever. And secondly, it's more easily linked to regulation and fiscal incentives. I mean, I've worked in energy efficiency probably for about 20 years, and really the only things that seem to work are offering an incentive or doing some regulation. And an interesting thing that we discovered quite a few years back was that in terms of incentives, it's not necessarily the incentive attached to the measure as much as attached to something else that can have the effect. There was a scheme in the UK where they were putting in cavity wall insulation, and they found rather than giving an incentive in terms of £100 off the cavity wall insulation, which most people didn't actually want in the first place, if you gave that £100 off the council tax, and they thought, oh, I'm going to get some money off my tax if I put this measure in, it was more effective. So once you start applying this to the building, there's a whole host of things you can do in terms of fiscal incentives. So what you could then do, you sort of take away to an extent this argument about systems, because you could then use the implementing measures through eco-design to actually review all of these fixed technologies, because the process that we went through in terms of preparatory studies and so on is really, really good. You could have actually looked at how that product or part of a system could be associated within a building, would fit, and how it would affect the building efficiency and the label. We could have gone through this process. I think that would have been an easy way to do it, but that's not where we are. And that's not where we're going to go, because that would take another 10 years plus to even start that again. So, but I do think it's important that whatever regulation we introduce, it has to be quite simple, quite light touch. We see things such as low voltage directive and the constructions product regulation, which are potentially affecting the same products. And it causes a lot of confusion out there. We need something that's nice and simple, ideally something that's nice and elegant, and will actually achieve the results. And I think that's what we should always try and focus on, what's actually going to drive better systems. So, and that was just to say the links of the directives. So, some more personal thoughts on possible practical interventions, so things that we could do now. What I would say is I don't think having a new directive on the energy performance of systems is the right way to go. I think that again, that's not where we are, and I think that we could tie ourselves up in a lot of knots. Let's just get out there and let's try and deliver something and actually make improvements on buildings. So what we could do, we could require member states to set standards for controls in buildings or building automation control systems using EN 15232 as a benchmark. Luckily enough, that's going to be in the UK building regulations from April of this year. So that's not a big stretch for member states because that's already the sort of thing that's starting to happen. And it means, again, it provides a tool for member states to set standards, which is very important. And we could also require member states to require regular inspections of BAC systems. We currently have those requirements for heating and air conditioning systems, and as I've shown you, that the control systems as well need regular maintenance. So both of those could sit quite nicely within the Energy Performance of Buildings Directive. Neither of them is a great leap. We could formally adopt the UBAC system label as a regulatory tool for these system inspections, because it's already there, it's already working, and in a few years' time there'll be a good base of auditors around the EU who can actually deliver this. So there is a tool to make that happen. And second, and these are relating to eco-design and energy labelling, we could actually start bringing together these provisional implementing measures that we've got for lighting controls, heating controls, and even smart appliances together into one implementing measure on building controls so that we can actually provide a tool to member states. And I think this is really important because the Energy Performance of Buildings Directive sets things that member states have to do. And there are certain things that do sit well within the member state scheme of things. And largely with systems and buildings, it's because you have to deal with installers, you have to deal with builders, and ideally you start to deal with the occupants of those buildings as well. But it's one thing to set a requirement that a member state has to set a standard. At the moment it says for technical building systems. It's quite another to actually be able to give them the tools so they can do that. So if they can actually say, well, here, under this implementing measure for controls, it's defined that in this type of building, these type of controls will lead to a C-rated environmental system or something like that, it gives them a tool to set standards. And that's it. An abrupt end, sorry about that. Those are our contact details. There's also an advert for an event that we're running in a couple of weeks' time, where we'll probably repeat some of this. But just to sum up, I think from our perspective, controls are really, really important. We need to get controls installed into buildings and operating effectively. And that's why I say let's try and use the tools that we've already got and not spend a few years prevaricating, because I think we could quite easily put things into the existing legislation and get some results now. Thank you.
Thanks very much for the talk. Are there any very urgent questions to be asked right now? If this is not the case, I would ask the second speaker, Alan Meyer from UC Davis Energy Efficiency Center. And the title of his talk is From Stovepipes to Umbrellas, Saving More Energy Through EU Policies.
Thank you for the invitation, and I hope that even though my title says boundaries, in fact, every time I speak of boundaries, you'll see these are really systems questions. And so I'm going to give 3 examples of areas that I believe are illustrate the kinds of challenges that exist now at the boundaries of eco-design and some of the other regulations. Let's just move forward onto one of them. How do I do that? Oh, yes, okay. So the first one is the topic of usability of appliances and products. You might also call that user interface, user friendliness, or less pleasant words. And the problem has been in the United States, and this is where my research started, was on the problem of thermostats. Now, thermostats in North America control about 10% of total energy consumption. So I think it's worthwhile to understand how these thermostats actually behave in the field. And surprisingly, there wasn't very much research in this area. But as we, and the basis of it, the stimulus of it was the fact that Energy Star in the United States has a program to endorse what they call energy-saving programmable thermostats. Two or three things happened. We began to find cases where the energy consumption of homes with these energy-saving programmable thermostats used more energy than the traditional manual thermostats. And that wasn't just one case study. We found there were several studies around the United States all coming to more or less the same conclusion. And as a result, Energy Star decided that they better study this a little bit further and actually shut down this program, this endorsement program, because they were not convinced that there were true energy savings happening. And as a result of that, then they went one step further and said, we won't restore this program until we figure out a way to fix this usability program, or usability problem. And I put down here at the bottom of the slide this important premise that they thought that improving the usability of the thermostats will in some way facilitate energy-saving behavior. They weren't responsible for that energy-saving behavior, but they wanted to make it more, they wanted to make sure that it could be harnessed. And this is actually where I got involved. And some of the surveys that we were participating in were kind of curious. I'm going to read this one to you. That we interviewed a person and we said, do you use the programming features of the thermostat? Answer, yes. Are you satisfied with the thermostat? It's okay. If you could have a new thermostat, what would you like it to do differently from your current thermostat? And they didn't want anything. And then we took a photograph of the thermostat and we could see that it was on what was called long-term hold, which meant they didn't do anything with this thermostat. It was fixed at a constant temperature. All the programming features had been disabled. We did another survey over the United States using something called Amazon Mechanical Turk, which is worth a completely separate story, and I'm not going to go into the details, but in the case of here we were able in 24 hours to do a survey where we asked people to photograph their thermostats and also answer some questions, and those were where they came from. But in 24 hours, we got that information. 20% of the respondents had the wrong time set on the thermostat, which means that they're using energy when presumably they weren't interested in it. 50% of them, half of them, had the thermostats on this long-term hold. They disabled all the programmable features, the energy-saving features. So we got involved in that. We're beginning to ask ourselves, how do you measure usability? And one of the surprising things we discovered was that nobody knew how to measure or quantify usability. And so this started a whole research area, and I want to show you an example of a video we took of somebody being asked to do something. Can you, come on, Nils, hop to it. Okay, so this is one of the tasks. We said, set the time of the thermostat. And I'll let this run for a moment just so that you can see. So this is a person in the laboratory. We've asked them to take this thermostat, set the time. And you know, whether they're doing, they're actually, you could see he was looking around trying to find some door or something to open or something. Maybe there were some more buttons. Now he's, you know, he's trying for, now he's going to the Game Boy kind of approach. And you get a certain kind of frustration. And there's a certain point where he starts just punching buttons. Yeah, now he has no idea what's going on. And you know, first we start laughing at this, but the fact of the matter is at a certain point there's an empathy, because we've all been in this position in one way, or whether it's in a hotel room or it's some other kind of control device. He's still looking for that, you know, some other secret way to set the time that he hasn't figured out. In fact, there was a door there, but there was no affordance, and there was no information to the user that how to open the door, and it was actually swinging a different, it was hinged in a different way. All right, so thank you. Now let's go to the next one. I mean, it really becomes sad after a while. So let's move on before we. Let's see right here, how to measure the product's usability. So one of our goals was to measure and quantify usability so that we could rank these thermostats, we could provide some sort of score, and then Energy Star could endorse the best and most usable thermostats. And yeah, here we go. And so in fact, what we did was we started creating this concept of measuring usability, which involved first defining a series of tasks, which to a great extent involved trying to figure out how do you quantify ability to accomplish them. And I won't go into all the details about the tests and the way we went through it, but the final result is we wanted to be able to compute some sort of usability score that Energy Star or other people, including manufacturers, could use to test the quality of their user interface. And in the case of thermostats, we developed a list of 6 tasks which we thought were necessary to fully exploit the energy saving and programmable aspects of these modern thermostats. And then we actually measured these the performance of people in a lab like this. We took these videos and tried to compare how the thermostats and to see what kind of range and usability existed. And these are the thermostats that existed. And this is one of the results we have, where on the horizontal axis is seconds to complete the task, and on the vertical axis is the percentage of users. And you can see that this task was simply turn the thermostat from off to heat, which is a fairly necessary operation. And yet, and you can see that I'm afraid to use this pointer. Let's see if I get. Yeah. So you can see that that 60% of the people achieve that in less than 30 seconds. But you can also see that there's some groups way over here, actually representing 15%, who took well over a couple minutes to accomplish a task. Now imagine you're in a freezing room or a freezing home and you spend 2 minutes trying to turn on the heat. It's not a good situation, and they are more likely to keep the heat on because when they leave, because they can't easily turn it off and on again later on. Well, that's one viewpoint. But another aspect that is important is to see what kind of variation there were among manufacturers of these thermostats. And you can see that among these manufacturers there was a range from 10 seconds for that task, that was the average, to over 80 seconds. So you can see that the choice of display, the choice of interface, the design of the interface could have an enormous impact on the success of people accomplishing that task in a rapid manner. And so to us, we wanted to make sure that the thermostat manufacturers over here were rewarded and some way recognized, because that's what consumers really want. And that, again, we hope will facilitate energy savings. We had other tasks, and you can begin to see how these things rank. This shows 3 of those tasks: setting the correct time, turning the thermostat on, and identifying the temperature the device is set to reach. And I'm not going to go into the details about these. Curiously, I will notice that the thermostat that actually was the worst was the one chosen by the consumer organization as recommended. But if you looked and see how they did the recommendations, they had people with laboratory coats sitting down comfortably in front of the thermostat, following the manual and everything, and that's how they chose that one, which is, of course, not the situation most of us are in. I certainly don't wear a laboratory coat in a well-lighted room when I adjust my thermostat. So this is where we were going, but in the end, we had to convert all this information from all the tasks into a single number. I'm not going to go into the details about how we did it, but it did allow us to eventually get to something that has a nice score of a thermostat, so that we could with a high degree of confidence, measure or quantify the usability of these thermostats. And you know, this does look a lot like, almost like an energy test procedure. It's a usability test procedure. It's a little bit different than we're used to in the laboratory for a refrigerator or a washing machine, but it's, you know, it's got a lot of the same features to it. So one could imagine that this is a supplement to eco-design. But you know, I'm pretty sure we'll get more thermostats. I know we're getting more thermostats that are more usable. On the one hand, we've got the Nest here, which Google just paid $2 billion for, and it's not entirely clear why. But the feature that is fascinating and absolutely essential for eco-design to worry about is the fact that it's interconnected. We already have about 1 million internet-connected thermostats in the United States that are helping the occupants adjust the temperatures and save money. And they are delivering a service as well in a way that we don't quite know how to measure and quantify, but that's going to be the next dilemma for eco-design, is how do you quantify the quality of a service? Because Nest and its competitors are delivering a different kind of service, and we don't know which one's better. At the same time, there are many, many, many lousy interfaces. Here's this. If I didn't say lighting control up there, you would have no idea what the switch is. It is also equipped with something that I call folk labeling, because the users of this never understood how to use it, so they started labeling it, and they actually put lousy labels on it, so they had to, somebody else put further additions on it. But the point is that you can see that here's this, when you have bad interfaces, people tend to find the simplest way out, and that often is a higher energy consuming solution. And I put this here partly because then you can think about how you would define the tasks to, again, measure the usability of lighting interfaces, which will be absolutely essential if we're going to have energy efficient controls. This is for our heat pump water heaters that are incredibly important as an electricity saving measure compared to resistance water heating. But if you get the controls wrong and you have time of use pricing, you can get a factor of 3 or 4 difference in your energy costs if you incorrectly set these devices. And you just, if you don't know that they've been incorrectly set, you may never notice it except for the bill several months later. And yet, this is what's coming, and we need to figure out a way to incorporate that, I think, in future eco-design regulations. So I think the moral of that story is that the efficiency doesn't stop at the product boundary. And I think that I just tried to illustrate in this some of our research, and maybe one of the way you can solve it. Now I'm going to switch topics, and now I'm going to talk about direct current appliances. These are appliances that operate with direct current, but not like your typical flashlight or something like that. This is a completely new area. What has happened last year is that USB and Ethernet have developed new codes or protocols that allow much higher power consumption to be transmitted on those cables. And so as a result, USB is 50 watts and Ethernet, power over Ethernet, is 100 watts. That's a lot of electricity and can run all sorts of appliances that you cannot imagine today with our current devices. And so already you're seeing homes in the United States that have this kind of system where here's our 115 volts and right next to it are USB connections. Because but it's not the correct connection. These are old USB and it's ideal. It's not exactly what I'm thinking, but you can imagine this is a sign of what's going to happen next. And here, of course, is USB, the same sort of thing. Now, what's to me most intriguing about this whole aspect of direct current that has a higher powers, first of all, it's a very different flavor of electricity than we have had in the past. It's it's a kind of electricity that is bundled with communication and information. And so that I would call it a higher quality electricity, and gives you many new opportunities to change and create devices that exploit this communication capabilities. And just to give you a sense, though, of what, how much power you can operate, a modern 600-liter refrigerator uses about 50 watts, but it's 50 watts average. Now, so you might think, well, right now you couldn't run it with DC, but maybe if you redesign that refrigerator, you could by putting in certain kinds of storage and so on. And in that way, you could operate increasing amounts of your home or your office building with DC in ways that initially might not be obvious. So I would say that it at least makes possible many energy-saving strategies for building. We don't really know how much energy it will save. I've seen some estimates of 10%. I think that's unrealistically low savings. I bet you that it can be much higher, but it will require redesigning many new appliances. But the thing that makes it intriguing also is that it allows you to have a kind of a future sort of pathway towards gradual integration of photovoltaic and even local storage in homes that might not try to put in an aggressive PV. They might want to put in it just a little bit there. And so you can imagine it entering homes through a combination of photovoltaic, some local storage, or that is batteries, plus a broadening, expanding USB or Ethernet network running those appliances. There are, I wanted to, as I said in the beginning, we're interested in the boundary problems, boundary issues, and systems matters. Well, DC, this higher power DC, shows has many examples of that. First of all, nearly every MEPS instantly excludes DC. And for good reason, because until recently, it wasn't an issue. But now you can run many, many, many more appliances with DC. This is not quite a joke. It's a USB microwave, and it's made to just do one container of beans, they said. But it illustrates that while in fact there is storage and there's a battery inside the bottom of this microwave oven right here, but it can be charged by USB, and that illustrates the kind of solutions that you might be coming up with. So first of all, all DC appliances are excluded from MEPS. The second thing is the test procedures for DC appliances haven't even been started yet, and the opportunities to redesign buildings so that instead of having a central fan, a central ventilation equipment, or just a central blower in a building, you might decide that it's actually more sensible to have a relatively small central chiller and have very small USB-powered local blowers bringing in the air that are all connected, because it's very easy to have plug and play through that kind of setup. And so you may be redesigning the building in ways that are actually much more extensive than just the appliance itself. But the fact of the matter is, I don't think it's going to be energy savings in any way that drives this shift to DC. I think it's going to be many other features that it has, and among them is the fact that you don't need an electrician to install these pieces of equipment. You'll just be able to plug it in, and there will be automatic recognition and communication and coordination of activities, and that will be attractive to certain groups of people. The other the other thing is that if you're worried about blackouts and energy security, you may want to have a DC system as a kind of a parallel backup system. And this is the way you can bring it in gradually and while providing other services. So these sorts of aspects may actually pull it much faster than energy savings. And so in that way, the energy aspects will be sort of dragged along and we'll be following this trend. Okay, the third item is the Internet of Things, and I guess what I want to do is describe it in this way, that I've been worried about standby power consumption for a long time, and I've been thinking about how standby power has changed so much over time, and so this pie chart shows more or less what was happening when I first became interested in standby power in 1995. The size of the pie represents how many appliances there were, and the green slice, how many had standby power. And then we get to today, 2015, plus or minus a year, right? And we're at a situation where, in fact, almost every product you buy now has standby power consumption. It may not be large, but it's now the situation where the exception is a product that doesn't use standby. I'm not saying that's good or bad. I'm just saying that's the way the situation has changed. I think there's some important parallels with what we've described as the network standby and network connections. That we've got this small pie today that a very small number of appliances have network connections. But in the future, I don't know whether it's 2050 or 2040 or something like that, but we're going to have many, 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 many more products with network connections. And I think it will, in fact, maybe approach and exceed the majority of devices. And this is really the network of the Internet of Things that are connecting to the Internet, and some of them are you might think silly, but others are very practical. I just subscribed to the Internet of Things last month. I bought not a Nest thermostat, but a Nest smoke detector. And so I have an apartment, a studio apartment that is connected to my house, and I always worry that my tenant removes the battery from the smoke alarm. And I don't think that's safe. Well, fortunately, Nest has now come up with a Wi-Fi enabled smoke detector. And so I can actually check on my smartphone to see if the smoke detector is working. And I think that's a great application. I paid extra for it, but I was actually very curious about the energy consumption of that smoke detector. Not because it's just one, but our codes require as many as half a dozen smoke detectors in our homes, and so we need to. Every time we do this kind of device that's connected to the network, we have to multiply it by a large number. And so that is a kind of example of where new devices are being connected to the network that we didn't have before. And so what I like to think, this is because Jürgen Sturm mentioned how the machines are talking, and I believe this is really what's going to be happening and driving a lot of the energy consumption, and so we need to be careful, considerate of that. But in fact, what I'm most interested in is the fact that the Internet of Things is actually the Internet of energy using things, at least from our perspective, and that we need to be prepared for that aspect, that many, not all of those devices will actually be energy using. And if we do it right, we might actually be clever and figure out ways of making that Internet of Things consisting of a large number of devices that, while connected to the Internet and our network connected, don't draw on the grid for electricity consumption. And so this means that we need to create very low power network connections that may draw on ambient power to run it. So this smoke detector I have, I was surprised, has a battery in it, which I couldn't imagine a Wi-Fi connection surviving on a battery for 5 years. But the way they designed it is it actually turns on the radio transmitter every 15 seconds or a minute. And so as a result, it manages to very cleverly conserve power. Now that's not a perfect solution, but it illustrates the routes you might go to join the Internet of Things without becoming a major energy user of things. So I think that this is going to be a challenge for us in the energy efficiency area to be part of the solution to the Internet of Things. Actually, not part of the solution, but a participant in the Internet of Things, and make sure that it's part of our friend rather than a problem. But I do know that regardless, at least in the trend, in the direction we're going right now, that the network standby, the network-related energy consumption is going to be very, very large and very significant. So I tried to give you 3 examples of how the boundaries of eco-design might change, and all of these have systems connections that the usability is essential. You need to consider the user as part of the product. And this becomes increasingly important as we aim towards the near-zero energy home. You cannot have a near-zero energy home without the participation of the occupants. And the only way you can engage the occupant and make sure that the occupant is part of the solution and not part of the problem is make sure that they understand what they are doing, the implications of their actions in controlling energy-using equipment. DC power, direct current power, is going to be potentially a new form of electricity and introduce all sorts of new kinds of appliances, or same appliances but now drawing on this new power. It has many different opportunities, though, to save energy, and we need to figure out how to do that. And then finally, this Internet of energy-using things, which I believe will drag energy use with it, in the sense that we're going to need to ensure that the products that are connected to the Internet of Things don't use excessive amounts of electricity. So thank you very much.
Thanks very much. If there are any urgent questions just regarding this. Yes.
René Kemna, VHK. Besides from being consultant, we're also a design office, and some 20 years ago we designed a thermostat for, at that time, the biggest manufacturer in Holland, Nefit, now Bosch and Buderus and stuff. And I was looking actually for the happy ending to your story. What we found is that, of course, having learned about ergonomics and usability in school and stuff like that, we tried to make something which is really very simple. But what we found is that they said, no, you can't do that, because you said it yourself, Consumer Association looks at the thing, they test it, they give it a good, but worse even, the thermostat is not bought by the installer, by the consumer, but by the installer. And they want to impress the installer, and the installer doesn't care about a simple thermostat. He wants something which has everything and makes him indispensable. Now, I was wondering, you did a lot of research. How did you solve it? How would you see the future on this?
René, I think I even remember seeing the illustrations of your thermostat. Yeah. So it's probably over a beer or two. But the point is that that is a very difficult problem, and it's the same one that Jürgen Sturm presented about the landlord-tenant problem, of that one person is responsible for making the energy efficiency investment or decision, and another one pays the energy bills. or in this case, and it operates it. And so the contractor or the installer puts in a thermostat that meets some criteria, that is attractive, but it's unusable. And I think I don't know how to solve that problem except to make sure that in some way the thermostat can be designated as more usable or less usable. And that was what Energy Star wanted to do. They wanted to say, we want to make sure that Energy Star had as one of its criteria for being endorsed that the thermostat was highly usable. And the manufacturers would seek to design their thermostats to be Energy Star compliant and therefore usable. And that's the only way we could figure out how to solve that dilemma, which pervades the whole energy market, that somebody's making a decision that is not in the end paying the energy bill or in the intermediate case operating the device.
And you succeeded in making usability criteria which are applied then? The usability criteria, you succeeded in making them, and
so we made them, and I guess I don't want to go into the long story of why they haven't been promulgated yet. That's for a beer, okay?
Okay, we now have time for questions on this session, so I would like to ask you to come up as well.
Carl Dolomar, Lund University. Thanks for 2 great presentations. I wanted to ask you something related to a research project that we did, where we asked industries and others about the smart grids and smart homes of the future. And there are many issues, of course, but 2 that I wanted to ask you is, first, are the homes, the smart or low zero energy homes of the future, well adjusted to the appliances and systems in those buildings? Some researchers think maybe not. And you seem to hint maybe at the solution using DC appliances to maybe have a less central system. So that's one thing. The other thing that some industries talked about was probably the poor IT security of home systems and the Internet of Things. That actually some of these companies will be amateurs in IT security, so it will be easy to access your data in these systems. I was very interested to hear your comments on this. Thanks.
I can partially answer that. We have in BEMA in the UK, we've got a Smart Grids working group and a Smart Homes working group who are trying to grapple with a lot of the issues and a lot of the changes as well that are happening as time goes on. I think on the second point, the issue of data security is something that is coming up as quite a big barrier, particularly I think in the media in some respects, and I think the consumer associations quite rightly are probably looking at this, and raising concerns about it. I think in some senses, though, data about what temperature you set your home at and so on is not really that crucial, and it's sort of the crossing across all of the different data. And I know that listening to a radio discussion about why Google had bought Nest, which was just touched on, it was about the data, because they can start refining the data that they collect on people by having that. I mean, you sort of wonder quite how useful that will be. They obviously think it's worth quite a lot, and I think it's a barrier, but it's not an insurmountable barrier. There are so many barriers to all of these technologies that in some senses it's just another thing that has to be grappled with. I mean, there are concerns about it, and there are measures being brought into place to address those concerns. But I don't think it's going to stop the progress, really.
I'll tell a story, because I don't know how to answer this question. I really don't have a good solution, but I taught a course called a graduate seminar on, it had the title Profiting from Smart Meters, because I figured the graduate students would tell me how you could make money from the data from smart meters. But I learned something, that apparently one internet matchmaking service wanted to get access to smart meters because they thought that they could detect when households were breaking up, and they would target those groups. And I thought this was the most ridiculous thing. For the course, I had been assembling access to various colleagues' smart meters, and one of them gave me her account number, and she was very trusting, I guess, and she said, then P.S. you can see where Joe and I got divorced. and well, sure enough, you could sort of see a trend of where the energy consumption changed in that household. But you know, I wouldn't have known that if I hadn't had that other piece of information that they'd gotten divorced, and then you can rationalize the change in energy consumption. But it is a real dilemma, and I would point out that while in both Europe and North America, you can see there's a lot of questions about the security and the privacy related to the smart meter data. The reason Google went for the thermostat data is because there are no restrictions. You know, Google's just taking it right off into the internet. It's got and it can use and repurpose that data however it wants right through the thermostat. And so they're going off, and you know what? In a sense, data finds its easiest way to flow. And I'm not comfortable with this either. And I wish I had something insightful to say, but I share everybody else's sort of, I think, uncertainty about how this should all settle.
My name is Dick van Orstok. I'm independent energy engineer here in Belgium. I was very happy with many of all of the presentations, but in particular with the last part on the network consumption and some biases, but in particular the network, because I already wanted to ask a question in the previous session, but there was no time for more questions, with respect to the lighting systems. So the parasitic consumption of lighting systems and the network consumption. I don't know if there are many studies and data available, but I have seen one monitoring scheme where there was a relighting and where they followed up in detail what were the results. So one floor was relighted, the other was not, and they had very detailed monitoring. And then they discovered that the new system, which was 2 times as efficient in terms of watts per square meter for the same 500 lux, that the new system had a lot of consumption at night because of these different detectors, present detectors, etc., and controllers. And it was, then they looked into detail, it was only very little, 2 watts per luminaire. But every luminaire in the office had his own presence detector. And that was 24 hours a day, 7 days a week, all year long. Also, in further research, it was found that just for having communication through the DALI protocol, many control gear of the typical control gear of many producers, manufacturers apparently, also consume around 2 watts to have this functionality, this network capability, which is often not known by the manufacturers themselves, because I give a little anecdote. The people who did the measurements in their lab then went to the manufacturer to present their results. They had used their equipment, their devices, and they said, well, we have measured 2.1 watt. And the people in the meeting room said, impossible. And they called to their workshop downstairs and they asked, measure that device and tell us. So 10 minutes later they called back from the workshop and they said, it's 2.3 watts. So this is just one more example of the issue which you have raised in general and which will become even much more challenging with the Internet of Things. And you have also indicated that there's doubtlessly a lot of potential to keep this under control and to minimize it. But I think there is still a great lack of awareness in the lighting community and the controls community in general. And even lighting systems, it's not something of the problem of the future, but it's a problem that exists for 10 years or more, and many companies still do not know it. So I think there is still a great challenge there. Also in the legislative context, this consumption should be evaluated and incorporated in product criteria and labeling and requirements before the bonus, or together with the bonus which is given to switching off and dimming, etc., and controls. Thank you.
I just thought our lighting controls colleague might be wanting to answer that. I don't know if he's in the room. I mean, I can't give any specifics on that example. I mean, except to say that, you know, if it is an issue, then it's something that we need to address. I don't think that we should be scared of, you know, moving towards the most efficient systems, but also, you know, in most cases, the savings that they deliver will dwarf the savings themselves. So if it doesn't, then there's a real problem that needs to be addressed.
But the market is changing incredibly fast, and so if you look at the web now, the number of lights that more for residential applications, I believe, that are Wi-Fi enabled is exploding, and they are so cheap. And you can easily imagine homes just installing 10 or 20 of these things, and before you know it, there's 50 watts of network standby, just running those individual lights. And I'm absolutely sure that we're going to that situation where every light will be addressable. And the question will be then, how do we ensure that not only can we address them in a way that is that controls them easily and effectively, but also ensures that the standby consumption is as low as possible.
Yeah, I mean, just to follow up, that's one of the points really in terms of saying that if the Commission's going to look at heating controls and lighting controls and smart appliances, then bringing them together, you know, is sensible, because, you know, if you've got a sensor that has some power consumption and it's just there for the lighting, that's worse than if it's also there for the heating and maybe a burglar alarm and smoke detection and everything else. So actually trying to bring things together is going to deliver benefits, but just allowing stuff to appear at random to create a system is not the best way to go.
We have time for one more question.
Aníbal de Almeida, University of Coimbra, Portugal. I have a remark regarding the power consumption of these wireless nodes. It's possible to do bad engineering and poor engineering. 15 years ago, the 1 watt initiative was very good, not anymore. In our pockets, we have a mobile phone whose consumption is around 100 milliwatt. So it's possible to design wireless nodes today with consumption below 100 milliwatt. And another strategy, which is being followed already by some manufacturers, is to use energy harvesting. Some sensors are able to retrieve energy if they have very low power consumption in the first place. Then they can extract energy from the surrounding environment, can be from light, can be from thermal energy, can be from vibration. And this is working in many millions of products. And I think this trend of having wireless nodes which are self-powered may be a way to avoid a drain on the internet of energy-consuming things. Okay.
Let's thank the speakers again.